Hi everyone, I hope everyone can hear me and has made it over from Stefan's keynote. After Stefan has talked a lot about what's to come in Flink and a completely new paradigm basically on how to build event-driven applications on top of Apache Flink. I want to take actually a step back and talk about how companies and particularly big enterprises adopt technology like Apache Flink, or at least how we see them adopting most of the times. And the way it usually starts is that there is some data processing challenge, data processing use case, data intensive application, and one of the team members proposes Flink could be part of the solution. So the team does a POC, they do some initial experiments, and it works out fine. There are of course challenges and some bumps because Flink is maybe not the easiest technology to adopt, but overall it works fine, and they move to production. So that's great, and they might do some internal advocacy, and additional teams start to pick up Flink, because in the end, Apache Flink can be used whenever you have a stream of data and you want to derive immediate insights or immediate actions from that stream. And these kind of use cases or these kind of requirements emerge in more and more use cases over the last years. So over time, there will be more teams that use Apache Flink for their projects, and they come from different backgrounds. They come from a different technology stack, and then basically the way they operate and they manage Apache Flink will also be different in each of the teams. And that's usually the point where an architecture group or an infrastructure group starts asking questions and basically makes this proposal. We could run a shared infrastructure for all streaming use cases. You get a sandboxed environment for each application, and the teams don't need to worry about managing Apache Flink anymore, but they can actually think more about their business domain again. And that's a compelling story. At Ververica, we have basically seen numerous companies over the last 4 or 5 years going through that journey, starting from the very early adopters over more traditional companies in the latest years. And it's our main mission at Ververica to make it easy for the companies from the point that they discover Flink to the point that they actually derive business value from Apache Flink, that they actually bring something into production. And we help companies through various channels, of course. There's the open source side with the mailing list, Stack Overflow, and of course the actual contributions to the code base. But on the other hand, there is our commercial product, Ververica Platform. And Ververica Platform is specifically targeted for this infrastructure team to run such a multi-tenant environment. So let's have a look at some of the features that it provides. And we'll start at the very beginning, deployment of the platform itself. So the platform basically has 2 requirements. You need a Kubernetes cluster, and you need a distributed file system or object storage. Once you have these 2 things, you can install the platform, and the platform will provide you with a highly available stream processing runtime or any number of these runtimes that you need. And you don't need to worry about picking or don't need to worry about state backends, high availability, restart strategies, and all the things that you usually need to dig through the Flink configuration, because the platform will provide you exactly these knobs and makes a reasonable pre-selection there. Since we only have these 2 requirements, you can basically run the platform where you're already running. So be it in the public cloud or be it on-premise. You pick your distributed file system, you pick your Kubernetes service, and you're good to go. One thing that we discovered very early when working with the initial big adopters of Apache Flink is that application lifecycle management for continuous stream processing applications is actually quite different than a classical multi-tiered two-tiered architecture or a batch processing job. The reason is just that you don't have these natural stateless points in time where you can do maintenance work, where you can make changes to your application or to the runtime. And the concept that Flink has come up with to tackle these challenges are save points. And in the platform, we have basically taken this a little bit further, and I want to talk through 3 scenarios through the lifecycle of an application where the platform can help you. So first, there's initial deployment of your application. The platform follows a declarative resource model here, similar to Kubernetes. So you specify how you want your application to look like, Flink configuration, parallelism, the application jar, and so on. You submit it to the platform, and the platform will take care that this application is running or is deployed and keeps running. Now, over time, your load might increase. Hopefully, you've built something useful and people start using it. And the parallelism, or you might decide you need to scale out. So in this case, you would just change the parallelism in your deployment specification, and the platform will take care of the rest. In this case, probably performs a stateful upgrade by taking a save point during in the process. Now, over time, it could also happen that you that in your data stream you find some data that you did not anticipate to be there, and your application cannot deal with the data and it crashes whenever it consumes this kind of data. Often this is called a poison pill in the data. So what Flink does in that case, it rewinds the stream from a point before that poison pill. What it means is you're in a restart loop, right? Whenever it consumes the data, it rewinds and it consumes it again. So in such a situation, you basically need to change your application so that it can deal with that kind of data, that it discards the record or just does something reasonable. So in the platform, that would mean you change the jar URI in your deployment specification to your next patch version with the fix. And now the platform will again perform a stateful upgrade, but this time not by taking a save point, because that's not possible while the job is in a restart loop. It's not running long enough to take a save point, but it will use the latest retained checkpoint that before the job started crashing. So these were just three scenarios where the platform can basically smoothen your second-day operations mostly. And the other area that I want to look at a little bit is multi-tenancy and security, because we think back this infrastructure team, or for this infrastructure team, this will be a major concern. The general approach to multi-tenancy in the platform are namespaces. So these are not Kubernetes namespaces, but it's a similar concept. So every team will get one or more namespaces for their applications, and everything that they do within these namespaces is isolated from the other teams. They create resources within this namespace. The administration team basically provisions these namespaces and manages the namespaces. One example of that is that the administration team, the infrastructure team, might provide some defaults for everyone. For example, might provide standard integrations for their logging and metric stack, and then every team can apply additional defaults on top of that. For example, if they align on certain ways to configure memory for their job, or to always use certain state package. In terms of authentication, the platform provides OpenID Connect for user authentication, and machine-to-machine authentication is via API tokens. So, for example, your CI/CD server would use an API token to authenticate itself to the REST API of Ververica Platform. Authentication is one side of the coin. Authorization is the other side. Here we follow a pretty simple, but I think flexible enough model where we have 3 roles per namespace: owners, editors, and viewers, and each of them has the permissions that you would expect from the name. In addition, there is an admin role which has global administration access and can provision namespaces. In terms of encryption, the platform makes it very easy to enable end-to-end encryption for all Flink components. That means between the components of the Flink cluster, as well as the communication between the Flink cluster and the Ververica Platform control plane, so the REST API of Flink. This is usually quite involved process. With the platform, it's basically a check of a checkbox in the deployment. The platform also comes with OpenSSL support out of the box, which gives you a very nice performance boost compared to the default OpenSSL provider that comes with the JDK. So in our benchmarks, we've seen up to 200% increase there. The software features are one thing. The other thing is the support that you get with the platform from the team at Ververica. So for every minor version of Apache Flink that we ship with the platform, you'll get 3 years of SLA-driven support for that version of Apache Flink and all the other components that come with the platform. Support levels up to 1 hour response or down to 1 hour response time. For production issues, we provide off-cycle bug fix releases for Apache Flink. So in between Apache Flink patch versions, you can get additional bug fixes from us. Of course, we do vulnerability and security checks, and then also fixes for all the components in the platform, including Flink. So this was the 5-minute rundown on Ververica Platform. This solves a lot of the issues and a lot of the requirements of this infrastructure team, and it's very well suited for an organization that already has that scale of a lot of teams running Flink. But there are also smaller companies that want to get started with the right tools right away. So 6 months ago, we started the startup license program. It has the full feature set of the Ververica Platform, and it's small companies up to 50 employees are eligible to it. Slightly relaxed support SLAs, but otherwise you get the full feature set. So that already increases the reach and makes it easier for more people to operate Flink. But there's still a gap, and this gap is basically for these early adopters in the company and everyone who's maybe not running Flink inside of such a company context. So we also wanted to make it easier for them, and that's why I'm very excited that we only a few days ago announced and released the Ververica Platform Community Edition. And the Community Edition will give you full feature set in around operations and application lifecycle management of the platform for free for an unlimited time, unlimited number of applications, and you can use it commercially. You can build your products on top of it. You don't even need to give us your name when you download it. So let's have a look at how this actually works, how you get started with Community Edition. I'll try to switch to the video here. So hopefully this works. So I said that the prerequisites are a Kubernetes cluster. So I have a Kubernetes cluster here, only the kube system components running right now, 2 namespaces, a VVP namespace and a VVP jobs namespace. VVP is for the control plane and VVP jobs is for the Flink jobs. The other prerequisite was a distributed file system, and I'll use S3 here. So I have a bucket, I think I called it Knauf VVP demo. It's empty right now. And for authentication, I've already created Kubernetes secret with the access key ID and the secret access key. Yeah, that's that. Now we can install the platform via Helm. So the platform is shipped as a Helm chart. For that, you need to add our Helm repository here. It's also, or you also find it on Helm Hub. If you search for Ververica, once we added that, we need a small configuration file. We'll not go into details. Basically, just links the platform to this Kubernetes to that S3 bucket. And now we can install the platform, give it a name, VVP, and pass this values file, this configuration file. And now we are asked to do one or two things. Either we provide a commercial license, which we don't want at this point, or we accept the community edition license. The community edition license is printed above, read it, accept it, and then you can get started. So now the components are starting to get up. Docker images are being pulled. And we're ready to go. We can port forward to the service of the platform. This will expose the REST API as well as the user interface, or the web user interface. We only use the web user interface now in this demo, but everything that we are doing now can also be done via the REST API. So that's Community Edition, and we see we don't have any deployments yet, so no Flink applications deployed. Not a surprise. In order to deploy our first application, we need to upload an artifact. So we'll do that real quick. I'm choosing top speed windowing with checkpointing here. That is the Apache Flink top speed windowing example from the open source project with checkpointing enabled programmatically. And the other thing that we need to create is a so-called deployment target, and a deployment target links the deployment to a Kubernetes namespace that you want to deploy this in, and I use VVP jobs, that namespace that I showed earlier. Now I can create the deployment. I give it a name. You also see there are two more tabs up there if I want more options for the deployment, but here the standard form is enough. I give it a name. I choose the deployment target. I choose the jar, and the parallelism I'll keep at 1 for this because I'm running locally here and I don't have too many resources on my laptop. So the initial state of the deployment is canceled. That's the default, and I start the deployment now. So now Ververica Platform will provision this Flink cluster and deploy the Flink job. And it should soon be done. It's done. We can have a look at the Flink UI to see that it's actually running. I know it's running, but we'll do it nevertheless. So we see the typical Flink UI proxied by Ververica Platform. So all the access control applies here as well. And we see the Flink jobs running here with a parallelism of 1, and it's processing some records. Now, if we go back and switch to the jobs tab, we see the history of jobs that used to back this deployment. Currently, this is just 1 because we have just started the deployment. And we can look at some details of this deployment. So here we see all the configuration of that job. Here we see all the configuration. In particular, we see that all the configurations around high availability, checkpointing, save points have automatically been configured for us. So this is production create Flink job that is running, that we brought up here in 3 minutes, 5 minutes or so. Yeah. So let's make a change to the deployment. We scale it up, change the parallelism from 1 to 2. And now the platform will just do its thing and perform this stateful upgrade. So it's taking a save point, migrate the state to a new Flink job that has a higher parallelism. That's done now. We can see what has happened in more detail in the Events tab. Basically, all the actions that happen during an upgrade. In the Jobs tab, we now see that there are 2 jobs. There's the job before we did the upgrade, and there's the current one. To wrap things up, let's cancel this deployment. We again see that it's transitioning. Generally, you have two ways to terminate a deployment. Either you use suspend, which is graceful shutdown, or you use cancel, which is a more quick shutdown that does not take a save point. So we used cancel now. We also see that in the different statuses at the end of the job. One is finished, the other one is terminated. And if we switch to the snapshots tab now, we see that there are two snapshots that the platform knows about right now. There is the one that has origin suspend. That was the one during the upgrade, the save point that was taken to scale up the job. And then there's another one, the retained checkpoint, that is the one that that's the last checkpoint before we cancel the job. So even though we canceled the job, the platform still keeps track of the latest state. So whenever you want to restart here, you can still use that. You can still do that from this this last state and don't lose any data. You can also fork deployments from any save point or reset a deployment to any save point in the past. So that's all I wanted to show for now. I'll switch back to the slides. And let's look a little bit ahead. So you've seen what the platform can do for you now and what Community Edition can do for you now. But probably you can also only use it if you're a Java or Scala developer, because if you always need some Scala, some Java to package your your Flink jobs, even if you write wrap SQL statements or table API programs. And we believe that there is a much broader set of use cases, much broader set of developers who could make good use of the streaming paradigm and Apache Flink. So what we will provide in the platform is an integrated streaming SQL solution that really opens up Apache Flink for more users based on Flink SQL. So imagine the same that we just did, but instead of me uploading a jar, I'm starting to write SQL in a web-based editor. And yeah, I'm going to leave it at that. I'm very much looking forward to talk about that in the next Flink Forward. The other thing that we're currently looking at is what we internally so far call Apache Flink Autopilot. So this will be a service that monitors your Apache Flink deployments continuously, and whenever it observes that something is wrong or something would need to be done, it will at least recommend these actions to the user. And the first thing that obviously comes to mind is auto-scaling here, and that's the first thing that we are currently working on in this area. So I hope this gave you a quick overview of the Ververica platform, made you a bit curious. If you want to try it out, check out this GitHub repository, Ververica Platform Playground, where you have some example configuration files to get up quickly with Minikube. And if you want to learn more, there is a 40-minute talk by Seth later today in track 1. Thanks, everyone.